This is section 8.4, and in this section we're going to be taking what we learned in trigonometry and applying it to word problems. Okay, so some terminology that's important. You have angle of elevation and angle of depression. So angle of elevation is the ground up, okay, from the ground up, and you almost always use this bottom angle. A common mistake is people will put the angle up here at this part of the triangle, but we almost always want the bottom angle here, okay? Angle of depression is used in just a few word problems, and that's when we have our visual line, horizontal line here, and then we're going down from there. So then we're going to be, this is our angle of depression, which we'll often be using. Okay, and I'll go over these again when we get to the word problems. But just one important thing to really note is almost all questions you're going from the ground up. Okay, so you're going to want to use this bottom angle is the one we use the most often. All right, so the only thing that's really new here is taking these words and turning them into a picture. And then once you do that, it's actually going back to just solving for one piece of information. You don't have to solve the triangle and find all the different information. In these questions, they're only asking you for one piece of information. Okay, so once you have the picture, then the rest is fairly straightforward. Okay, so let's read this question and draw a picture. Standing 250 meters from the base of a cliff. So let's see. We have a cliff. Let's draw a cliff. Here is a cliff. Okay, there's a cliff. And we are standing 250 meters from the base of that cliff. So here's the ground. And here's us. Okay? And we are 250 meters away. So, standing 250 meters from the base of the cliff, there is a 31-degree angle from your feet to the top of the cliff. So, like this, okay? And almost always in these cases, you want to put the angle here. So the 31 goes here. And I didn't like that this is not a straight line. Let's make this straight. Oops. Oh, there we go. Okay. So, where was I? Okay, so, and then it says, how tall is the cliff? So they want to know this height. So from here to here, this side, X, how tall is the cliff? Okay, so we have our triangle now. We know that it's a right triangle. Here's our right angle. We have an angle here. We have a right angle. We have one side, and we want to know this other side. So the first thing we're going to do when we solve this is we're going to label our triangle. So we have our hypotenuse over here because it's across from our right angle. Okay, then here's our reference angle. We're going to go across from there, and this is going to be our opposite. And then our last one is going to be adjacent. Then we are going to circle our information. So we have information here and here. And now we can say, so we're looking for side X. We have opposite and adjacent as our two pieces of information. And so we can use tan. So now we can write our formula. Tan of an angle is equal to opposite over adjacent. We can fill in the information that we know. Tan, and we see our angle here is 31. And our opposite is X, and our adjacent is 250. So because our number here is, is on the bottom. We're going to move it. So we get 250 tan 31 is equal to x. So then I can put that in my calculator. 250 times tan of 31. So I get x is equal to 150.2 meters. And I used one decimal place because here it says round to the nearest tenth. And then because this is a word problem, I'm going to write my sentence. The cliff is 150.2 meters tall. And that's my final answer for this question. All right, let's look at another question. A Douglas fir tree, 85 feet high, casts a shadow of 47 feet. Okay, so start off, we're going to draw the ground. Wait. There, we're going to draw the ground. Then we're going to draw a tree. So here's my tree. I don't know. This is a terrible tree. Whatever. All right. There's my tree. Okay. So my tree is going to cast a shadow on the ground. So, I don't know. Here's my shadow. Okay, that's a shadow on the ground. So it says the tree is 85 feet high, and the shadow, the shadow's small. Oh no, I did too much shadow here. There we go. The shadow is 47 feet. And we want this. Here's our sun over here. So it says, what is the angle of elevation of the sun? Okay, so whenever we talk about angle of elevation, we always talk about the ground up. Okay, so this bottom angle. Don't be fooled into using this one. Don't do that one. This one, bottom up. That's what we want. So this is the angle that we're looking for. Okay, so we're going to, this is our right angle here. We're going to label. No, I'm going to label in pink so it's clearer. This is our hypotenuse. Here's our angle, so across. This is opposite. That's adjacent. So we have opposite and adjacent, so we're going to use tan. So what are we looking for? Angle. Opposite and adjacent. So we're going to use our TOA. So tan of our angle is equal to opposite over adjacent. We want the angle, so we're going to do the opposite of tan, tan to the -1. Our opposite is 85, and our adjacent is 47. I'm going to put that into the calculator, and I get 61.1 degrees. This is also to the 10th. So 1 decimal. Well, whoops, sorry about that. So I'm going to say the angle of elevation of the sun is 61.1 degrees. Okay, next question. A pilot is required to approach Vancouver Airport at an 8-degree angle of descent. That's another word for angle of depression. So now we're getting the second type that I was talking about before from the beginning. If the plane is traveling at an altitude of 10,000 feet At what horizontal distance from the airport should the descent begin? All right, so as always, we're going to start off drawing our ground. Okay, that's the ground. It's always best to draw the ground first. Next, we're going to draw our plane up in the air. So, whoops, let me try and draw a plane. Let's see. Like that. And like that. I don't know. It kind of looks like a plane. All right, there's our plane. And the plane is how high? It is traveling at 10,000 feet. So we know that this here, that's 10,000 feet. Okay, so now we need to draw a line of sight, a dotted line, and it's saying that it needs to approach Vancouver Airport at an 8-degree angle of descent or angle of depression. So let's say the airport is over here. Here's our, oops. Here's our airport on the ground in front of us, okay? And saying that this here, this angle is 8 degrees, okay? Now, there's a rule that you need to know about. If you have a straight line like this, in two straight lines like this, wait, there, okay. Whatever this angle is, it has to be equal to that angle. Meaning that whatever we have up here is going to be the same number down here. Okay, this is just a math rule. Okay, you should have learned in previous classes. So this angle is going to equal this angle. So that means that inside here is going to be 8 degrees. Okay, so if we have an 8-degree angle of descent here, we're going to have the same number here. Okay, so now we can solve this angle, or this question. So it's asking us, at what horizontal distance from the airport should the descent begin? So that means that how far away from the airport, so they want to know this distance here. So we'll call this X today in our question. So now we can label. Here's our hypotenuse. And this is our angle over here, so that means this is our opposite. I can circle this. And this is our adjacent, and I can circle that. Oh, we're using tan again. So we have, we're looking for side X, and we have opposite and adjacent. So we're going to use our TOA. So I can fill that out now. I have tan of my angle is equal to opposite over adjacent. Tan of 8, so 8 degrees. And my opposite is 10,000 over X. My X is on the bottom, so I'm going to swap. I'm going to continue writing over here. X is equal to 10,000 over tan of 8. So now I can put that in my calculator, and I get 7,153.7 feet to the 10th again. And, oh yeah, I have to write a sentence. Ugh, I don't have a lot of room. Well, you know, you get the idea. Oops, hey, why did that happen? Okay, so you would write this as a sentence. The descent should begin when the horizontal distance to the airport is, and then, what is that? 71,153.7 feet. Oops. All right, last question. The equal sides of an isosceles triangle are 30 centimeters. and the third side is 36 centimeters. Determine the measure of the interior angles of a triangle. All right, so this one's a little bit trickier. So let's draw our triangle. So isosceles triangle means that two of the sides are the same length and then one side is a different length. So let's draw a triangle here. Ooh, terrible. Let's try again. 1, 2, 3. Okay, and it's saying that this is 30, this is 30, and this one is 36. Okay, and then it wants us to figure out the internal angles of the triangle. Well, we can't do any of our techniques on this because it is not, it's not a right angle triangle. So we need to cut it in half so that we can make a right angle. So now we have a right angle triangle, okay? So we are going to ignore this half and just focus on this half over here, okay? So, So I'm going to redraw my triangle down here, just the half that we're focusing on. So I know that this is 30, and if I took my 36 centimeters, I'm cutting it exactly in half, so I get 18 centimeters. I know this is 90, and I'm trying to find this angle down here. Okay, so in the end, I want to find this angle, and this angle, but I'm focusing just on this one to start. Okay, so I'm going to label my triangle. I know that this is my hypotenuse because it's opposite my right angle. And here's my angle, so that means this is my opposite and this is adjacent. So I have information here and I have information here. I'm going to find angle, and I have hypotenuse and adjacent, so that means that I'm going to use my cosine. So cos of my angle is, oops, I wrote that wrong, is equal to adjacent over hypotenuse. So cos of my, oops, I want the angle by itself. Cos to the -1. My adjacent is 18. My hypotenuse is 30. So my angle is 53.1 degrees. Okay, so I found this is 53.1 degrees. So I remember when I'm dealing with an isosceles triangle, the angles that are opposite the identical sides are identical. So if this one is 53.1 degrees, that means this one is 53.1 degrees. So I know now two of my angles. These two are both 53.1 degrees. To find this third one, it doesn't matter if this is a right triangle or not, all three of these angles still has to add up to 180. So now to find the third angle, the top angle, I'm going to do 180 minus 53.1 degrees for my first angle, 53.1 degrees for my second identical angle, and I get, when I do that, 73.8 degrees. So my three angles, the three interior angles are 53.1 degrees, 53.1 degrees, and 73.8 degrees. Okay, so now you can go to page 325 and do questions 1 to 5, number 9 and 10, and number 12 and 13. And that's it for this section.